Hello folks, so this is part one of two of my DIY Arduino based powered hacksaw. I'm going to do a couple of videos on the infrastructure that I've got, and it might give people an insight into what is required for the potential, if they have a notion of restoring their own boat. You'll see that I do have a fair bit of tooling, but it can be done even in small spaces, including flats in Glasgow. This is of my design. It is got two limit switches, and each time a limit switch is engaged, the hacksaw goes in the other way. It's relatively simple to program, as all you're doing is changing the direction of the motor depending on if a limit switch is hit. A lot of the powered hacksaws that you'll see online don't use this system. I think this is kind of my own notion. I'm sure somebody's probably done it before, but most of them are mechanical in nature and use a sort of a pistoning type mechanism on a rail, turning circular motion into linear motion, which I'm doing, but in a different way. The big advantage to this is that I can manipulate the stroke of the powered hacksaw. So as you can see, the limit switches are on separate rails. And with the separation of these linear limit switches to the rail itself, means I can adjust it. Now, when I make the stroke longer, it limits the width of the workpiece notably. Now, the shorter I make the stroke, counterintuitively, the bigger the workpiece can be, because the stroke is reduced. And I don't think that is an option when it comes to the powered hacksaws. Not that I've seen on YouTube so far anyway. It's relatively simple to do. I've just bought some roller bearing guides, which don't actually seem to be doing much of the rolling, but they are doing the job. Some aluminium plate, two aluminium rods, one limit switch, two limit switch. I think that's a NEMA 23 motor. We've got an Arduino board. This one's complete overkill for the task, but this is a Mega 2560. We've got a buck converter, which just means that I don't need a separate power supply. So the buck converter is changing 24 volt into 5 volt to power the Arduino, and the driver essentially accepts small electrical signals from the Arduino, which are control signals, and it then sends them to the motor, as well as more power to the motor to make it move back and forward. And that's kind of the principle of this powered hacksaw. What I'm going to do now is I'm going to cut out a piece of aluminium sheet. I'll attach everything to it, mount it to the wall, and then have a play, probably make it a bit quicker, and then start cutting some material to see its performance.